Hello and welcome to this short video on leading zeros. So over the last couple days, there's been a few questions about some different scenarios. For example, we're always working with 8-bit binary numbers, but what happens if I enter a number in the Windows calculator and it becomes 1111? That's not 8 bits, it's 4 bits. How do I handle that? So in this video, we're going to talk about leading zeros and how they affect our numbers. And before we come back to this binary example, we're going to look at regular numbers that we're used to. So for example, if I write the number 6, well, I can put a 0 in front of that, and it's still 6. I can put 2 zeros in front of it, it's still 6. I can put as many zeros as I want in front of it, and it's still 6. However, if I ever put a 0 to the right of 6, it changes the value. Now it's worth 60. So if I do 600, that's 600, that's 6,000. So anytime we're adding zeros to the right, it's changing our place value. Anytime we're adding zeros to the left, it doesn't change anything. We can put them as much as we want. In fact, we can take 60 and add a 0 in front of it. That's still 60. That's still 600. That's still 6,000. As such, that's all base 10 numbers that we're quite used to. So now let's look at what happens when we're working with binary numbers. So if we have this binary number here, which is 1 plus 2 plus 4 plus 8, so 15, if we put 4 zeros here, we still have the binary digit 15. So this in base 2 is the equivalent of 15 in base 10. Leading zeros don't affect binary digits. If we have 1, 0, 0, 1, 0 in base 2, we can add 3 leading zeros to get it up to an 8-bit digit. It doesn't change the value because place value starts over here. 1, 2, 4, 8, 16. We could fill those in, but they're all zeros. So we have 16 plus 2, and this is 18 in base 10. So if we have something like 1, 1, 0, 1, we can put as many decimals as we need to go up to 8 bits. If we wanted to, we could go to 9 bits or 10 bits. We're not going to do that in networking, but we could. And the values are still not changed. Oops, sorry, that's an 8, and that's a 16. So we have 8 plus 2 plus 1, which is 11, base 10. Now this example leads to a really confusing situation for some people and something I want to make you aware of. 1s and 0s exist in both binary and base 10. So if we're looking specifically at an IP address, let's say we're looking at 10.101.1.1. This address is a dotted decimal. Okay, this is an IPv4 address and it's written in dotted decimal, meaning this is 10 base 10, this is 101 base 10, this is 1 base 10, and this is 1 base 10. This number written out in binary would be 0000 8 plus 2 dot 101. I'm going to grab the Windows calculator to quickly calculate that. So I come back to the calculator, just move it into your view. I switch to binary or to decimal mode. I type in 101 and I see the binary value is 0110 0101. So I had 0110 0101.1, which is a whole bunch of zeros followed by a 1.1. So I don't want you to be tempted to think that because this address over here is using 1s and 0s that it's written in binary. It's not written in binary. Binary will always have 8 bits. So each octet will be 8 bits. It won't be written with a single bit or this. It will have the leading zeros. So if we're looking at this particular example, we can see leading zeros, leading 0, leading zeros, and leading zeros. It will be written in that form. It will not be written in a shortened form. So be aware that when you're looking at something like this, you are still looking at dotted decimal and not a binary address. So some people are having some issues with that, and I just wanted to clarify. So hopefully you find this was helpful to you. And it's clarified some of the leading zero situation that can happen with binary and dotted decimal, mostly when we're working in IPv4. So hope you found this video helpful. Do let me know if you like this format with the black background and the lighter colored text. Some people had said they prefer videos of that format, so I'm going to try that out for a bit.